Petchy's Corner, we're going to look at solving quadratic equations by graphing. Now, a quadratic equation in standard form, we've talked about this before, is ax squared plus bx plus c is equal to 0. Now, when you find the solutions, whether by graphing or by factoring, there's a couple different phrases or names that we use to talk about the solution. We sometimes call it our roots. We call it the x-intercept, where it either touches the x-axis. Sometimes it crosses the x-axis, but anywhere it touches. And we also call them the zeros. Now, again, we looked at this before, but just as a reminder, solutions of quadratic equations. If there's two solutions, it's going to touch that x-axis twice. One solution, it's going to touch it once. And again, these can open up or down. No solution is where it's not going to touch at all. All right? So we're going to graph some today. Besides factoring, you can also find roots by graphing, which is what we're going to do. If exact roots cannot be found, we're going to state the consecutive integers which the roots are located. All right, so let's look at number 1. We're going to graph, and we're going to graph like we have in the past. We're going to start. We have a is equal to 1, b is equal to -1, c is equal to -6. So first I want to find my vertex. So my vertex, remember, my x value is equal to -b over 2a. That gives me positive 1 over 2 times 1, which is 1/2. Now, to find the vertex, I need to substitute that 1/2 back into my function, my original function, to see what my y value is going to be. And in this case, it's -6.25. Okay, so you can make that 1/2 0.5 if you want. Either way is okay. And I'm going to put that again in the center because that's my vertex. I'm going to put that in the center of my table. And like we've done in the past, I'm going to pick values around it. Okay, and then from there, we're going to graph them. Now, if you want to pause this video and try to graph them on your own or substitute the values in, you are certainly welcome to do so. All right, -2, 0 is there. -1, -4 is here. 0, -6. 0.5 and 6, -6.25 somewhere in there. 1, -6. 2, -4, and 3, 0. All right, I'll do the best I can since we're graphing by hand. Okay, now, our solutions are remember where they cross the x-axis. So this crosses the x-axis right there, and we have another one right here. Now, if you notice on our graph, the x-axis is where the y value is 0. So we can even use our table. The x-axis, when we're touching the x-axis, is where the y value is 0. Okay, so our solutions are going to be -2 and 3. They are our roots or our solutions or our zeros. Okay, now remember, just let's go back. Think about this. If I were to factor this, like we've done in previous lessons, I get x minus 3 times x plus 2. X minus 3 is equal to 0. X plus 2 is equal to 0. So x is equal to positive 3 or x is equal to -2. It's the same thing we have when we graph on the table and ultimately our roots. It's just a different method of looking at it. All right, let's take a look at number 2. And again, we'll do the same thing. My a value is 1. My b value is -6. My c value is 4. Okay, let's find the vertex, which again is -b over 2a. It gives me positive 6. 2 times 1, that gives me 3. I substitute back into my original function, and I have my vertex is 3, -5, 3, -5. Again, I'll put numbers around it, substitute that in, and then I'll graph it. Let's see what happens. See if we can find those zeros. So I have 0, 4 is here. 1, -1 is here. 2, -4. 3, -5. That's our vertex, so it should start coming up. 4, -4. 5, -1. And 6, 4. Okay, and again, I'll do the best I can, graph it since it's by hand. You want to make sure it looks like a U and not a V. All right, so at this point, you can see when I looked at my previous graph, I could definitely tell where it touches the x-axis. In this case, it's off a little bit. I don't really know. It's somewhere, right? Is it a half? Is it a quarter? Is it a third? Same thing over here. Is it 5 and an eighth, 5 and 2/7? We don't know. So in this case, remember, we said if we can't find it, we're going to talk about the consecutive integers where the roots are located. So remember, it touches the x-axis when and it crosses the x-axis when it goes from a positive to a negative or vice versa. So let's look at our table. That happens there and it happens there. Okay, this is where it crosses the x-axis. And here's where it's crossed the x-axis. Okay? And again, if you look at our table, that's and our graph, they are together there, right? Somewhere between 0 and 1, and then somewhere between 5 and 6. We don't know exact. So again, if we don't know for sure, we're going to say that the roots are somewhere between 0 and 1, and also somewhere we have 2, somewhere between 5 and 6. And that's the best we do. We're just approximating. So we're going to stay with that. Okay, again, just gives us a good visual. All right, last one for today. We're going to use a quadratic equation to find two real numbers. So a quadratic equation, I know that has to be x squared. Two real numbers that have a sum of 6. So sum we know means to add. And product of negative 55, we know we're going to need to multiply. Now, quadratic equation, I'm not using an x and a y here. I'm using a quadratic equation, so I can only stick with one variable. So if you think about this, my first number, my unknown, I'm just going to make that to be x. Now, if my sum is 6, that means if I subtract my first number from 6, I'll get my second number. So we're gonna start with that. Okay, now we're going to multiply to get to negative 55. So here's my first number. Here's my second number, and I'll multiply to get to negative 55. All right, I'll distribute it. 6x minus x squared is equal to negative 55. Now, again, I want my leading coefficient to be positive, so I'm going to bring both of these terms to the other side. And I have 0 is equal to x squared minus 6x minus 55 is equal to 0. Okay, I'm going to factor it. Now, again, there's my x squared, right? We started with my x squared up here. That's a quadratic. That's what the directions told us to do. I know I have a plus and a minus. Factors of 55 either have 55 or 1, 10 and 5. I'm sorry, 11 and 5. So when I subtract, I get 6. So my higher factor is 11. I need that attached to the negative sign since that's what I have there. And that's my 5. So I have x plus 5 is equal to 0, or x minus 11 is equal to 0. So x is either equal to negative 5 or 11 and 11. Okay, there are two numbers, so we're going to try them. Again, it's always great with these word problems, and you're like, I think I did it right, but I'm not sure. If I add them, negative 5 plus 11 gives me positive 6. That's what I wanted. Check. Looks good. My product means I'm going to multiply. So I have negative 5 times 11 gives me negative 55, which is what I wanted. That doesn't really look like a negative. Let's change that. Okay, that's what we wanted, right? Negative 55. That's done. Check, right? So it says find the numbers. So my numbers are 11 and negative 5. Okay, great job today. Have a good one.